Hello, my name is Eduardo Valério, and in these videos I'm going to talk about system identification. That is to say, I'm going to talk about how we can find a model for a system from data on how the system behaves. This data on how the system behaves will very often be experimental data. It need not be so. We can find a model for a system from some theoretical knowledge about how it should behave. This is sometimes done, for instance, in controller synthesis. We design a controller so as to have some action on the system that we want to control. And then, from the desired behavior of the controller, we identify its model so as to use it in the control system. But the usual situation is that in which the data we use for identification is experimental. So here's what I'm going to presume as default. We have a system, we perform some experiments, we collect data during those experiments that shows how the system behaves, and then we carry out some calculations using that data to find the model of the system that we want. Notice that what I've just described is called offline identification. On the other hand, in online, or better said, in real-time identification, data collection and model identification take place at the same time. New data that we keep acquiring is used to iteratively improve the model we are identifying. This is possible, but in these videos, I'm going to presume by default offline identification. The subjects I'm going to address can be found in my lecture notes. If you Google my name, you will find my web page at Instituto Superior Técnico, and here in Materials for Classes, you can find not only this YouTube channel with these videos and other videos for other courses, you can also find the lecture notes of signals, systems, and control. These lecture notes of signals, systems, and control have 8 parts, and these videos concern part 6. There are 4 chapters in part 6. These videos are organized into 4 classes. Each of these 4 classes corresponds to one of those 4 chapters. This first class corresponds to chapter Overview and General Issues, in system identification, of course. Now, to follow these videos and to learn what I have to say about system identification, you should know something beforehand about systems. Let me tell you what you can find in these lecture notes that you need to know beforehand to follow these videos. First, you have to know about the Laplace transform and the Fourier transform. You can learn about that in chapter 2. Then you have to know what a transfer function is. You can find that in chapter 4, sections 4.1 and 4.2. The other sections in this chapter are not necessary. Everything in part 2 is necessary. Systems theory is very important. You have to know what block diagrams are, what an open loop and a closed loop are. Then you have to know what time and frequency responses are, what the steady state response, the transient response, stability, and frequency responses are. You should also be able to read easily a Bode diagram. In the last chapter in part 2, we have other things you need to know. Time and frequency responses of transfer functions with pole at the origin, a pole somewhere else, second order systems, and then how you can find responses in frequency and in time for systems with several poles and zeros.
Here in part 3,
you must have basic notions
filters
about
and bandwidth in chapter 12, sections 12.2 and 12.3. The other sections in this chapter and the other chapters in this part are not necessary. Finally, you should know something about digital signals and systems. That's chapter 25. In chapter 26, you should also know what these approximations between the S and the Z planes are. You need not know anything about approximations of controllers, since this is not a course on control. Finally, from chapter 27, you need to know about block diagrams of digital signals and systems, pole placement, and then frequency responses. These are the 3 sections that you need to know. This suffices for the first 3 chapters in part 6.
For chapter 33 and for the 4th class in this series of videos,
you need to know something about nonlinearities. You can find that here in chapter 8, section 8.3. Then in chapter 24, where delays are addressed. And finally, in chapter 28, I repeat that these last 3 things, soft nonlinearities, delays, and this chapter on hard nonlinearities, these 3 things are only needed for the 4th class. These videos on system identification will be followed by other videos on fractional order systems and on stochastic systems, corresponding to parts 7 and 8 of these lecture notes of signal systems and control. These other subjects, fractional order systems and stochastic systems, are also related to system identification. When we reach these subjects, you will see why and how. Let me stress that it is very important to know systems theory to learn about system identification. This is because much of what you have to do to identify a model for a system is to reason backwards. When you learned about systems theory, you learned to see how, given a certain model of a system, this system behaves. You learn to find time and frequency responses. So now you have to reason backwards. Given a certain time or frequency response, you have to find the model that describes the said time or frequency response.